1 in topic 4. Today we're talking about properties of equality. And today we're going to talk about how to keep an equation balanced. So let's get started. You already know how to write and evaluate expressions. Today what we're going to learn is that you can use two equal expressions to make an equation. And that's what we're getting into today. It's something that you have been learning since like kindergarten. But we're going to actually learn how it works and why it works today. So to start off, we're going to use an example. Think about a scale, right? If you've got a scale that there's like a fulcrum in the middle and then either side is going to bounce, right? If you're on a teeter-totter or a seesaw, right? If both people weigh the exact same amount, it's going to be balanced. It's going to stay the same. When I think of this, I think of something like Mulan, right? The old man says, a single grain of rice can tip the scale, right? A single grain of rice can tip the scale because it's going to throw them out of balance. If you have 100 grains of rice on this side and 100 on this side, and then you add 1 grain of rice, this side is going to have more quantity, so it's going to tip down that way. With an equation, it's the same thing. If we have the same expression on each side, if the quantities are the same, it's going to be balanced. We can put that equal sign in the middle. And that's what we're going to talk about today, so let's go ahead and get started. Flip to your PBIL section, and we will take a look at our first problem together.
Did they send me daughters? I asked for some.
To start, we're going to start with a real difficult problem here. We have 5 plus 3 equals 8. So go ahead and take a second, just kind of marinate in that problem, just think it through. And once you've established that 5 plus 3 is equal to 8, we're going to look at these two quantities. Is this equation true? Well, yeah, both sides have a value of equal to 8. 5 plus 3 is 8. So it's safe to say that 5 plus 3, we could write on this side that 5 plus 3 is 8. And 8 is equal to 8. So this equation right now is equal. So what are some things that I could do to this just to play around with it and keep them both equal? Well, what if I want to, I'm going to put this down here, what if I want to add 5 to both sides? If I add 5 to both sides, will that keep this equal? Will my equal sign still be true? Well, let's see. If I put 5 over here and 5 over here, 5 plus 3 is 8 plus 5 is 13. Is 13 equal to 8 plus 5 of 13? Yes. So if I wanted to, I could add 5 to both sides. Now let's stay with this original problem, so I'm going to get rid of all this extra. You keep yours in your PBIL section because remember, you're writing everything that I do. So what if we wanted to, for the second time, what if we wanted to add 3 to the left and 5 to the right? I'm going to put R for right. 5 to the right. So if I add 3 here and 5 here, do we have equal? Will this be an equation? Will this be equal? 5 plus 3 is 8, plus 3 is 11. 8 plus 5 is 13. So that's not equal. So that wouldn't work. What if we tried something a little different? Instead of adding, what if we tried to, for the third one, we're going to divide the left by 2, and then we are going to multiply the right by 2. So we're going to take 5 plus 3 and divide it by 2. We're going to take 8 times 2. 5 plus 3, we had said, was 8, and then divided by 2 is 4. So 4 equals 16. Well, no, it doesn't. So we can't do that. Let's take a look at one more. Oh, how you doing? For the fourth one, what if we subtract 4 from both sides? That's sloppy over there. That's all right. Minus 4, minus 4. 5 plus 3 is 8. We're going to take away 4 from that. We're going to have 4. 8 minus 4 is 4. So that one worked out. What I want you to do is just kind of stop and think for a second. Did the operations that I did the operations that I did affect this original problem? I'm going to rewrite it. 5 plus 3 equals 8. If I did addition, subtraction, multiplication, well, that's division, or multiplication, was it the operation that affected it, or was it something different? Well, if we go back and look through our notes, you're going to see that in different operations, sometimes it would work, right? If I did add 4 to each side, it would work. But what if I add 4 to one side and add 5 to the other? Are they equal anymore? Not if they started out equal, right? So when we have an equation, we have to do the same thing to each side if we want it to stay equal. And that's kind of what we're getting into today. So stay in your PBIL section, and we're going to do one more quick example. So remember, an equation is a number sentence that uses an equal sign to show that expressions have the same value. So here's our new problem. 10 minus 4 equals 6. Is 10 minus 4 the same as 6? Yes, 10 minus 4 is 6. So each side of this equation are equal. What I want you to do for this unit, and kind of just from now on, just think of this equal sign. Rather than looking at this as one long thing, think of the equal sign as two separate sides. Whatever is on this side, you want to be equal to this side. Whatever is on this side, you want it to be equal. So when you have an equal sign, your goal is to get them balanced. You want to have 100 grains of rice over here, 100 over here. Or in this case, 6 over here, so this side is going to be 6. Whatever is on one side of your scale needs to be equal to the other. So whenever you solve an equation, really all you're doing, 10 minus 4, what is the quantity on this side? Well, it's 6. So I know that over here that's going to equal 6. Or I could write that as 3 plus 3, or 5 plus 1, or 9 minus 3. Whatever is over here, my quantity needs to equal 6. Go ahead and flip to your guided practice section, and we'll take a look at this a little more in depth and walk through it.
Mr. I'll make a man out of you.
All right, now we're in guided practice, and what I would like for you to do is go ahead and copy this problem down. And I'm going to give you a few seconds here to do it. It says, if 12 plus 18 equals 30, which it does 12 plus 18 plus 5 equal 30 plus 5? So go ahead and get that copied down. And I'm just going to kind of wait here while you do that. And
maybe do a little dance. Oh, I can see across the street in the apartment someone's watching soccer. That's pretty cool. And do a couple push-ups. 1, 2, 3, 4, 5, 6, 7, 8, 9. You didn't see them, but I did them. All right, hopefully that's copied down now.
So if 12 plus 18 equals 30, does 12 plus 18 plus 5 equal 30 plus 5? Well, let's look at our original problem. It's 12 plus 18. Well, look, there that is right there. And then 30. Well, there that is right there. So all that we did to this one is we added 5. And since we added 5 to both sides and didn't change anything else, then yes, they are equal. So that's all that we're really looking into, is that we're looking at properties of equality. So with the addition property of equality, if we add the same amount to both sides of the equation, then we're following that property and we're following the rules. Let's take a look at another one. Here's number 2. Go ahead and copy this one down. If 4x equals 20, does 4x divided by 4 equal 20 divided by 5? This time, go ahead and pause it, and then once you have it written down, join back in. Welcome back from pausing your tape. What we are doing here is we are checking to see if we used a property of equality. And looking at the operation here, it looks like it's going to be the division property of equality. So that is one that we can do. We can use division on an equation because we can use any operation we want. But the division property of equality states that if we divide both sides of an equation by an amount, it needs to be the same non-zero number. So that means it can't be 0, can't divide by 0. But if we divide by the same number, then we're good to go. It's great. Let's look. What number did we do? We've got 4x in our original problem, 20 from our original problem. And here is our new number, 4 and 5. Did we divide by the same quantity, the same value, the same amount, the same number? Well, no, we didn't. So 4x equals 20 would not work in this case because we cannot divide by 4 and we cannot divide by 5. What would make it true? Well, if either this one was a 5 or if that one was a 4, right? If we are going to divide an equation, we have to divide by the same quantity. If we're going to add to an equation, we have to add the same quantity. So if we want to keep an equation equal, if it's already been equaled, we have to use the same amounts. That's what we're getting into today. That's what hopefully we're catching on with. We're going to do 2 more problems and then you will take your quiz. Here's our next problem. Go ahead and pause it and catch up if you need to. Our new problem reads 35 minus 7 equals 28. And yes, in fact it does, so I put a little check mark here. That one works. So we're already equal. Knowing that we're already equal, that means that we can use our properties of equality. But what we're going to check and see is, did we use the property of equality correctly here? So for here, here's our original problem, 35 minus 7 equals 28. So what property of equality were we attempting to use here? Well, if you look at the operation, we have division. The division property of equality says to divide both sides of an equation by the same non-zero amount, because remember we can't divide by 0. So did we follow the property? We divided by 7 here and by 28 here. Did we follow it? No. So it's pretty cut and dry. If we're not using the same amount on each side, it's not true. So you might see it in different ways. So like see how we have 35 minus 7 in parentheses. That's saying that we have to do that part first. We have to do our original equation first. So don't let parentheses throw it off and extra numbers. All we're checking to see is what we did to each side and if it's fair. Keep it fair. That's all I ask. Let's look at number 4. Here's our last problem. It's number 4. And here's what we have. 23 plus 43 equals 66. Let's say that I decide to take this side and multiply it by 3. If I multiply this side by 3, what am I going to have to do to make this side still equal? Well, this would be the multiplication property of equality, and that says that we're going to multiply both sides of the equation by the same non-zero amount. So again, we don't want to use 0, it's just going to make it nothing over here. So if I multiply that side by 3, then that means I have to multiply the other side by 3. And that's going to keep it equal. So last class you had your vocabulary section. We copied down all these properties of equality. The properties of equality are just saying, as long as you are doing the same thing to both sides, you're good to go. To sum things up, kind of give us some closure here. From now on, just think of the equal sign as the center of a balance. Okay, we have 2 people over here. We're going to say that Mr. Hall is over here and someone that weighs the same as Mr. Hall is over here. If you're being nice to this person and giving them cookies, you gave them 4 cookies, all I ask is that you give Mr. Hall 4 cookies. And if Mr. Hall wasn't a good boy and he loses 2 cookies, take 2 cookies from them too. Keep it fair. If you decide that Mr. Hall needs to share his cookies and divide it among his one and only friend, and you are sharing that between 2 people now, so if we're dividing this by 2, each person's only going to get 1 cookie. Each person should only get 1 cookie over here. All right, that's all we're doing. We're just keeping the equation equal, keeping it happy, keeping the balance from tilting. And go ahead and take your quiz. Email me your score, and I will see you in class tomorrow.